All right, great. Well, I think we are ready to start here. Thanks everybody for joining. It's very good to see a lot of people attending and many familiar names too. So officially welcome everybody to our webinar today. I'm going to go ahead and start sharing my screen. Here we go. Our webinar today, it's called Unlocking CCUS. So we're going to talk today about the technology, collaboration, and the commercial readiness. And joining me today, we have two experts from our network, which I'm going to introduce in a minute here. So this is going to be the agenda for today, pretty straightforward. I'm be starting with a very short introduction, and then we get into meeting our two experts today, Stephen and Lionel. And then that we are going to get into the meat here. So the thematic discussion, we have 3 or 4 questions planned for today. We've been receiving some questions also from the audience before the webinar, which is great. We'll try to address them while we go. We're going to follow the main discussion with our CCUS database. I'm going to walk you guys through some of the findings through the database that are related to the thematic discussion for today. And then we'll leave hopefully around 10-15 minutes at least for questions from the audience. Just a little bit of housekeeping. You all should see a button there to submit your questions. Feel free to submit them at any point. If you do that before the end of the session, we'll try also to answer those as we have the discussion. If not, we can dedicate some time at the end of today's webinar. And if there are any questions that we don't get to answer today, we'll get back to you in the next few days. So without further ado, let me get started with a little bit of introduction in case anybody here is not aware of or familiar with PreScouter or what we do. So we were founded roughly 15 years ago with our headquarters in Chicago in the US. And what we do is strategic research consulting. We've completed over thousands of projects in these last years with hundreds of clients. What we typically do is we try to provide to our clients the latest with respect to research, to strategies, markets, insights. We do that thanks to our global network of experts, and we have 2 of them here today that we're going to help us through this webinar here. If anyone is interested in learning more about what we do and examples, always happy to have a short discussion. Myself, I'm the technical director for what we call the natural resources and energy vertical here at PreScouter, and I'm going to be moderating this webinar. So let me please briefly introduce our experts today. So we are bringing 2 experts, one more on the side of the industry, that's Stephen on the left side of my screen, and then more from the academic viewpoint, it's Lionel here. Starting with Stephen, he's bringing more than 30 years of experience across different sectors, primarily the industrial gases in general and decarbonisation. He's held very important positions such as global head at Linde, and then he has been advising different institutions and organizations such as the European Commission, and played a key role in shaping the clean hydrogen strategies, for example, that we're now being deployed across the EU. So you'll hear today insights from him that are not just research, but really from these over 3 decades of experience in the trenches of industrial transformation, let's say. On the other hand, Lionel, he's a senior researcher and coordinator for CO2 capture and utilization at Mons in Belgium. So he's definitely one of the Europe's leading academic voices when it comes to CO2 capture and utilization. He brings almost 20 years of experience in actually post-combustion CO2 absorption and process engineering in general, and has won multiple prizes, as there's an example in here, and has participated also in very interesting collaborations. For example, the one with Heidelberg Cement, where his research is really helping bridge the gap between lab scale innovation and industrial deployment, in this case in the cement sector. So thank you, both of you, for participating today in the webinar. Now let's jump directly into some of the questions or topics we have planned for today. And we're going to start with a tough one, which is what's holding CCUS back. We've got a couple more questions around this topic from the audience as well, such as people are interested in knowing when will the projects take off, and what is in the way of success to those projects here. So maybe with that relatively open question, maybe Stephen, if you want to start here sharing your thoughts about what's holding CCUS back. I believe might be muted here. Let's see. All right, I cannot hear you. Is it just me?
No, I think it's muted. If you can hear me,
I can hear you. Yeah.
Yes. So Stephen seems muted. Yes.
Perhaps you can. Perhaps you can hear me now. Is that better?
You are back.
Good. Excuse me. There we go. Beginners luck or teething troubles, whatever. So, well, the question really is, well, what do we need to achieve CCS, so carbon capture and storage? Well, fundamentally, we need the right technologies, the right infrastructure, and the right business case. And if any one of those is going to fail, be absent, then we can't achieve CCS. I think, having said that, I'll make it sound very, very simple. We must also recognize that even if all of those things are put in place today, the gestation period to achieve large infrastructure projects such as carbon capture and storage would still be 4, 5, 6, 7 years in terms of planning, building, constructing, financing, regulatory approvals, etc. So I think, in addition to being anxious that we get CCS done, we must also sometimes be a little bit patient and realistic about how long it's going to take to jump some of those hurdles.
Definitely, yeah, definitely a good point there. Lionel, what's your take on that?
I think Stefan summarized quite well the main elements of this problematic. I think there are different, which is complicated in that topic, and I would like to start with that, is that I see personally differences depending on the location. So when you are talking to persons from United States, from Europe, from Asia, from Australia, there are common, let's say, common aspects, but there are also many differences. And so that complicates quite well the discussions, because I see that when I have contacts with several industrials, is that the industrial strategy can be really different depending on the location. So I wanted to highlight this aspect directly to say, okay, what we will discuss today, maybe the answer is not the same if you are coming from the United States or Europe or another place. One aspect highlighted by Stefan, and I agree on that, is the fact that we need CCUS, and I would like to push this by highlighting that in some sectors, and I, as you mentioned in the introduction, so I work quite well with the cement sector, but we are working also with lime producers and other industries. They have what we call unavoidable CO2 emissions. So they have no choice. So it's linked really to the raw materials decarbonization. So the CO2 emission cannot be avoided. And so we need absolutely to apply CCS and CCUS to reduce significantly the CO2 emissions. And so coming back to your question, what's holding CCUS back? I think one of the main, let's say, critical gaps to reach that is the fact that it's still expensive. We need to be honest regarding this. Stefan was talking about business cases, and this is absolutely mandatory. We need to find conditions to have business cases, but that would be really easier if the technology was cheaper, as we imagine. That's the reason why advancing and on the technology and applying the technology is absolutely needed, because what we see in different sectors is the fact that you can decrease the cost by applying the technology. So we need absolutely to create the conditions in order to facilitate the implementation of CCUS. And in that point, maybe we will discuss about this today, but there are many dimensions. So you have cost dimensions, what I mentioned, and then we can enter into the details of technical aspects, limitation and specific aspects depending on each sector. But I think these are the main points regarding this problematic. So the cost aspect, technical aspects, and we need to work on both sides.
Excellent, great. And I think, well, one aspect that you both mentioned was the cost, right? And particularly, Lionel, you said that in order to decrease the cost of the technologies, you can achieve that by applying those technologies. But it's difficult to apply those technologies because they are costly today. So there's a little bit of a vicious cycle there. I'm interested to hear from you guys. How can that be breaking here? Like, what is the role of different policies and incentives?
Let's take that. And again, we've got a nice question in the chat from Mark Ashford, who's asking to what extent is regulation and state goals involved. And I think that's totally on point to your question there, Christian. What I said was wrong was the business case. I didn't say it was too expensive. I said the business case was wrong. And the business case can be encouraged by a lot of things. So for example, if there's a high cost of CO2 emissions to atmosphere, for example, through the ETS, the emissions trading scheme in Europe, or other schemes around the world in Switzerland and Norway, Sweden, you're going to be paying more than 100 euros per ton of CO2 emissions, even if the European emissions trading scheme is down at 70 or 80. If you look in the United States, there's the 45Q tax credit. These work in different ways, but they're similarly putting some money into your business case to encourage people to do CCS. However, when we say even in the United States, $75, $85 per ton of CO2, $120 a ton in Sweden, €80 a ton for the ETS. These amounts, these penalties or these incentives are generally right on the edge or just below what's going to drive a sound business case. So what I think, what can we do? I mean, Lionel has already talked about scaling up technologies, and of course, as they scale up, costs will come down. But I think critically, what we need to be doing is two things related to bringing down the overall cost. Clearly, the governments can put up the incentives or put up the tax hurdles more. Great, we create a business case that way. But if we were to focus on the cost, I think there are specifically two things we need to focus on. I don't think the capital cost of the CO2 capture equipment is the issue. It's the energy intensity of the CO2 capture equipment. So we need to be focusing on CO2 capture equipment that requires less electrical power or less heat energy. And specifically, that's all related to the regeneration of the solvent or the adsorbent. So we need to be thinking about things such as physisorption instead of chemisorption that needs less energy input to get the CO2 back out of the solvent or the adsorbent material. Such as MOFs for adsorption, for example. I think that's a good technology direction to be going. The other huge area where we can bring down the cost is what I mentioned earlier on in terms of the infrastructure. It's about the on-site CO2 capture costs, yes, but then we need to move that CO2 from a cement plant or from a steelworks or from a coal-fired power plant to where it can be sequestered or utilized. And you've started out talking about CCS, sequestration. So it could be 1,000 kilometers, it could be 1,000 miles between point A and point B. How are we going to move that CO2? If we're moving it by a road tanker, it's insanely expensive and we're never going to be able to afford it. If we're beginning to move it by train, things begin to get a little bit more sensible. If we can put it on a barge or a ship, yep, this is actually beginning to look quite nice. But if we can put it into a pipeline, then the CO2 transmission costs will really, really, really fall away. And then when we look at capture costs, transmission costs, and storage costs or sequestration, geological storage costs, if we can bring that transmission cost right down with an effective CO2 pipeline infrastructure network, then we've really hit one of those three main cost elements right on the head. And this is what I was talking on earlier about, what do we really need? We need the business case, the infrastructure, as in the shared infrastructure, the port terminals to store liquid CO2, the ships to take CO2 out onto the offshore storage sites, the pipelines to move CO2 around cost effectively, and we need the business case. So what extent is regulation and state goals involved? I think regulation can really help to drive the business case. Furthermore, when we're permitting the offshore storage sites, allowing the CO2 to be buried underneath the ground, then of course regulation and permitting becomes really, really important. And as I've talked about pipelines there and long distance CO2 movement, if we're inside the United States, inside of one country, it's okay, we're interstate, but it's still one country and it's kind of manageable. As soon as we start talking about Europe, for example, or Southeast Asia, for example, in Southeast Asia, it could be straddling Singapore, Malaysian, Thai borders, or Indonesian waters. In Europe, it could be emissions starting in Austria, moving through Germany, through France, through Rotterdam, through the Netherlands, into the North Sea. And then the European Union is great, but the United Kingdom's not in the European Union. What if we want to bury it in a UK sector of the North Sea? So when we talk about regulation and state goals, it's also a lot about collaboration across borders to move this waste material through pipelines or ships or trains across borders and manage it safely and monitor it safely to make sure that the international harmonization is there also. So thanks for the question, Christian, and also Mark, and I hope I've given it some justice.
Absolutely. Thank you for your thoughts there, Stephen. And while you were talking about particularly this last part, there was a good question also coming from Rafael. So he's asking about all these different steps you were mentioning, right? The transportation to storage. The question is whether in your opinion, the piping operator, whether that should be also the same company that operates the injection, or is it better if the model has different companies across different roles? Do you have an opinion on that, Stephen? What?
I think the closest parallel that we can draw on to understand how industry has evolved is to look to the oil and gas sector. I appreciate, not everybody's a big fan of the oil and gas sector in terms of being, largely responsible for a lot of the fossil fuels that we're using, some of the CO2 emissions problems, but they can also be a fantastic learning for us in terms of how to manage these complicated infrastructure projects and supply chains. And I'm sure they can also play an absolutely massively critical role in solving the problem as well. And the fact the European Union has mandated that the oil and gas operators allocate CO2 storage capacity. But I think if you look at the oil and gas world, you've got upstream oil and gas operations drilling oil out of the ocean. You've then perhaps got pipelines bringing it to refineries, and then the supply chain breaks. If you think about upstream gas, it's kind of similar. You've got upstream gas exploration and drilling and extraction. Then we've got pipeline distributors in Europe, such as SNAM, SNAM, the big Italian pipeline operator, who are separate from the upstream operators. So a pipeline operator focuses on managing and building and constructing infrastructure pipelines. The upstream operators focus on the geology, the undersea geology, where's the oil going to be underground, or in this parallel, where can we bury the CO2 underground? So I believe what will happen is 3 or 4 players within a value chain in terms of capturing the CO2, certain technologies, moving it by rail and liquefaction, let's say certain technologies and specialists, rail operators, logistics operators, leasing companies, or specialist pipeline operators. And then we're talking about ports and terminals and shipping operators. And then we're talking about geological sequestration. So you can imagine 4 or 5 critical blocks in the value chain. And I wouldn't be surprised if we see specialized entities focusing on 1 or perhaps 2 adjacent blocks within that value chain, very similar to what we've seen, how the oil and gas model has evolved.
Perfect. So that's a great insight there. And I think maybe this is a good segue for our next question, which I also think it's tied to Ahmad's question here, which is a little bit more about technologies and maybe opportunities for innovation. So I think, well, Stephen, you mentioned, for example, MOFs. I know, Lionel, you're very involved in discovering or researching new technologies. There's MOF, there's membranes, there's absorption. and there are also mineralization technologies. And for example, my question as well, whether could be an option to inject it into the tailings of the CO2 producers using the right technology. So maybe Lionel, I can start with you with this one. With that context and the technologies here, where do you see the opportunities for innovation?
Well, I think there are many opportunities for innovation, and we are, as a, let's say, a university representative, and we are following and we are developing different solutions. I would like just to come back to one point, but which will make the links with these questions. But regarding the last point where we were talking about infrastructures and especially CO2 transportation, one important aspect regarding CO2 transportation is the specification of the pipelines. We see this in my area, for example, the pipeline, the pipelines is under, let's say, establishment, and they are defining some specification, and the specifications are evolving and becoming more and more drastic, and so that influence the choice of the technology. That makes the link with your questions, because I have some contacts with industry are saying, oh, the specifications are becoming so low, so small in terms of SOx, NOx, and other impurity levels, that finally applying an amine-based technology becomes very complicated, because we will need to add the supplementary blocks to purify the CO2, etc., etc. So just want to say that this is an important point also in innovation, is having, okay, efficient technologies at the cheaper level as possible and efficient, but also generating a pure CO2 flow. And I think it's important to highlight that, because when we are talking about technologies like membranes or adsorption, as you mentioned, most of the time what we see is that there is a, let's say, a trade-off to find between high recovery level and high CO2 purity recovery. You see, that's the reason why we're working on developing different new materials, both for adsorption or on membranes. And you mentioned the MOF, and we had at the University of Mons the MOF for Air project regarding MOF development, and we really believe that there is a big potential for this technology. Regarding membranes, there is also a potential. We need to continue to advance and make some tests in most realistic condition as possible. But an important aspect is also the validation at large scale. This is an important aspect, because when you compare with the amine-based technology, which is clearly not perfect, even if I worked a lot on that technology, I recognize that we still need to improve this technology, but we have an advantage. we have seen that we can apply this technology at very large scale, and this is maybe a difference with some other technologies which have very interesting potential, but when we think about very large scale, maybe that will be more complicated, and such kind of technologies maybe will be more adapted to smaller scale in the first step. Maybe on the long term, I really believe we will see more and more technologies applied on bigger scale. But at short, mid-term, it's really complicated to have at both sides validated technology, in realistic conditions, and at the same time having this technology able to capture a large amount of CO2 and at a high level of purity. You see, so this is it's always a trade-off between different factors. So we are talking about absorption technology. We follow a lot this technology here, and we work on that. There are several potential for reducing the cost and having new technologies. Talking about new solvents, especially, for example, we are working on demixing solvents. So I don't know if everybody is familiar with that, but demixing solvents, just to say very quickly, it's when you capture a CO2, you can form two liquid phases, one which is really rich in CO2, one which is lean in CO2, and as you can regenerate only the rich phase in CO2, at the end you regenerate a smaller flow rate, which is richer in CO2, and so you decrease your energy consumption. So this is one possibility. We are working on that. There are also more advanced solvents like ionic liquids or such kind of materials, but as I mentioned, this is maybe at a lower TLR level, and we do not have necessarily always the possibility to have large amount of such kind of products. So we can synthesize ourselves these products, but sometimes we can have a very interesting solutions based on literature. But in practice, when you have the question from an industrial, oh, I would like to test this technology at this level, well, it becomes complicated at the moment to test this. But I really encourage all the industrial to test this technology at the level. We need absolutely that, but we know that it's still expensive and not always easy to have project to fund that. But again, and I think Stefan made the link with that. He talked about the different location around the planet, and I come back to that. But it's really important to keep this in mind. It's really different depending on location. So what I'm saying here, for example, based with my European vision, let's say my Belgian vision, but maybe in United States or Asia, Australia, maybe they will have a different vision on that technologies. What I would like to say to conclude this part, if I would like to say one technology that I see which is well, really going forward in the development, it's cryogenic technology and the hybrid technology combining, for example, adsorption and cryogenic. Why? Because when you apply a cryogenic technology, you can generate a very pure CO2 flow, which is able to be injected in the infrastructure, transport infrastructure that we were talking just before. And so I see this at the moment. There is a real interest for cryogenic technologies, and we are also involved concretely in projects where we will apply this technology and test and improve this technology. So this is one, let's say, one thing that I see at the moment is that cryogenic technology are really receiving a lot of interest. But I don't kill the amine-based technology, because personally I'm really convinced that it's very interesting, efficient, and that there is still some room for improving this technology. If I may, just one last point regarding amine-based technology. One of the characteristics, and that was mentioned also by Stefan, is the energy consumption for the solvent regeneration. And we need thermal energy for regenerating the solvents. And what you have to know and to keep in mind is that all the industrial plants does not have waste heat available. I'm talking about certain cement plants or lime plants, such kind of plants. It's not like power plants or waste to energy plants. They do not have a steam network available. And so in that case, one innovation on which we are working is also the electrification of such kind of processes. So being able to consume electricity instead of consuming directly thermal energy. And I think on that topic, it's really important to advance because when we will be able really to propose an electrical, fully electrical amine-based solution, which works also at large scale, I think amine-based will come back well on the table for discussion. So I think that's it. I don't want to be too long, so I don't know the other questions that you want to discuss, but that was several aspects regarding the technologies. But we could discuss about that during hours.
Absolutely, and I appreciate the insight, Lionel, and sharing things like the mixing solvents, the ionic liquids. Those are really good innovations. Maybe last one, since you talk about amines and their potential, but also their some of the struggles they have, the thermal energy requirement, for example. There's a question from Frank. That's a good one about amine emissions and degradation products, and what's the trend in Europe regarding regulating those things? Do you want to comment on that?
I think there are clearly regulations around the emissions to air and also to emissions to water, because the amines end up in the wastewater, which should be treated and cleaned, but some of them slip through, and again emissions to air, and also we can end up with ammonia as a decomposition product. So there are emissions levels set for these various different things. I am personally concerned about the carcinogenic effect of some of the amine degradation products. And when I'm looking at technology selection for CO2 capture, if I'm seeing, let's say, a waste to energy facility which is in an urban environment, what I'll be suggesting that my customer looks at is a hot potassium carbonate solution as a liquid solvent, which is an alternative solution. It works very similar to an amine-based solution. It's a liquid solvent, but it avoids the amine decomposition issues. You also then need to think about what's the oxygen concentration in the stream and all sorts. So yes, I think this is a very, very relevant point. I've also seen some people who are investing in CDR removal certificates, so people like Microsoft and Amazon. I'm not trying to name anybody in particular, but some people who are investing in CO2 removal, CDR removal certificates, basically specifying that the technology that has been used to capture the CO2 and sequester it is, X, Y, and Z, or avoids A, B, and C. And I have heard things being said about them wanting to avoid amine-based solvents. So the question that Frank is asking is clearly very hot, very pertinent, very real. Whether or not we'll see a tightening of regulations of emissions to air and water from some of these amine-based systems in the future, I don't really know. But what I would say is there are clear alternative technologies that work extremely well that people can use. So even if the world said we can't use amines ever again as from tomorrow, do you know what? CCS would still go ahead.
Great point. Excellent. Thank you, Stephen, for that. I think, well, we've covered many parts of actually the next question we have planned here, which is the collaboration models that work. So particularly you, Stephen, you talk about the pipeline operators, the upstream business, all the different roles in there. But maybe we can still dedicate a few more minutes to this. Maybe we can touch upon some of the struggles that have been mentioned before, that are some of these alternative technologies, let's call them, or innovative technologies that could replace the amines, for example. They need to be proven at scale.
I think when we look at collaboration models, I don't think we need to look too deep into the technology. I think we've been there in our recent conversation. I think what we need to look at here is people who are linking value chains, or people who are looking at the value chain and then taking that to an industrial emitter and trying to offer them what we refer to as CCS as a service. So basically, drawing a line around the factory and saying you capture CO2 and drop it over the fence and I will do everything else with it. Or even going onto the site and saying that's your chimney, send me your flue gas and I will then capture the CO2, send you your flue gas back, you can stick it back up your chimney and I'll run the capture facility, you need to provide me with steam, if you can't then I'll buy my own natural gas and burn it or whatever, right? But basically, when we look at collaboration models, I think where we need to begin to start going is accepting that the whole idea of getting into CCS for a cement plant is completely alien to them. Or the idea that a steelworks should suddenly become a CO2 capture and sequestration expert is a fantasy. These people are brilliant at making cement. These people are brilliant at making steel. It's what they've always done, and it's what they're always going to want to do. Do they make their own power? No, they buy it from a local utility supplier. Yeah, so I think we need to understand that there's a huge collaboration model here for people who are willing to focus on the CO2 management, industrial CO2 management, industrial carbon management, and either own the problem from the boundary, from the site boundary, or even go into the site itself and own the problem within the site and take the CO2 directly out of the flue gas and do everything else that they need to do it from there. And they will then build the value chain with whatever partners that they need to partner with to basically take the problem off somebody else's hands. And that means that the cement plant can focus on making cement excellently. And somebody else who's brilliant at putting together CCS or industrial carbon management value chains has taken that problem off their hands and probably done it, if I might say, more effectively than the cement plant could, because it's the 17th time they've done it this year. Whereas for the cement plant, it's the first time they've ever done it. So again, I see that these collaboration models will absolutely come into play, and they will enable people to focus on their strengths and their core strengths and their core business models, which means that we will see a completely new business model emerge, which is basically industrial carbon management, let's say, as a service, with all of the infrastructure, with all the partnerships built into that. It might be a very, very capital light model that owns nothing, except a few really great contracts with some other great second-tiered service providers. Or it may be a very asset-heavy business model that owns a lot of infrastructure in terms of pipelines or railcar assets and whatever. But I do see that collaboration across the CO2 management value chain will be absolutely essential. I think we'll need to see experts emerge who are really great at doing this, who can go and offer these kinds of services to other industry sectors who basically want to continue to be able to focus their energies and capital resources on doing what they do best, which might be making steel, might be making cement, or might be making glass or something else.
Thank you, Stephen, for those insights. I think they're spot on. Lionel, would you also like to comment on the collaboration models for CCUS?
Yes, maybe I will comment on my level, which is more linking with academics. What we see, which works quite well, is when we can associate really academics, private and public also partners. Why? Because we need also to help the public partners to understand the CCUS, because most of the time what you were explaining, Stefan, was very, very correct. And most of the time, the persons that need to decide, and we have a great, huge importance in all this discussion, is politics. And sometimes we have difficulties to be clear with the politics and to explain to the politics that sometimes even private partners are coming to us saying, oh, can you explain this to the politics representative? Because I can take an example in my area in Belgium. We have let's say a small potential for CO2 geological storage, and the political representative in my region are totally against geological storage. Even if we show that there is a potential, we show that it can be safe, because we have an experience regarding such kind of activities, and also the operator mentioned previously. But even with all these elements, they said, no. What we want is a circular. We agree to inject the CO2 in a network, pipeline network, to send the CO2 in another place, but we do not want to think about storing CO2 in that region. And I think that's a pity, because we can show that it would be cheaper to be able to store the CO2, closer to the industrial activity. So it's just to say an example regarding the collaboration models. We need really to create all this framework with all the stakeholders which are important for the decisions that are around the table. And regarding academics, I think we can have an important role naturally for innovation, and so being able to be there for testing the solution and proposing solution at a smaller scale, and then helping for developments and being near the industrials for understanding all the phenomenon, because when you test new technologies, you can sometimes see different things, different phenomenon, and so we need to help the industrials to understand that. And we have the industrials, and so also public partnerships, because we need to have this intervention of the public partner saying, okay, in our area, we really create conditions to increase the capacity of the industrials to capture and use or store the CO2. And so it's what I say as the model. I think we need the different stakeholders to be around this table and to help for the development of the CCUS, and taking sometimes some models that were used in other sectors, because sometimes you see that with for example renewables energy or other activities, and that's possible. So I think if it's possible with other industrial activities, that should be possible with CCUS also.
Thank you, Lionel. Let me ask you one follow-up question, Lionel, because you mentioned that some of the challenges when it comes, for example, for scaling up technologies and prove them at scale, which is missing today. It's really bringing on the emitters, the technology providers, the policies around it. And you have participated in different collaborations with the industrial sector to sort of test some of these new technologies. In your experience, what's the key to set up those collaborations between the academia, the emitters, the different stakeholders? Are there any silver bullets there for making that happen?
But most of the time it's a question of, sorry to come back to that, with budget and the cost. Most of the time we make some estimations of what will be the cost to be able to test the technology, and the industrial needs to make an investment. So I agree with what said also Stefan at the beginning of this webinar, that the problem most of the time is not the capital cost, but more the energy consumption. I agree with that. But when we are talking about just preliminary or pilot test, is always difficult for the industrial, to make the investment just, if you say this, just for a pilot, but it's always complicated for industrial to say, okay, we go full scale directly. So I think this is one of the important aspects there, is really to start from the lab scale, micro pilot scale, as we have here at the university, and going to a sufficiently big scale, and without any support from European authorities, European projects, or other public system or public allocation, I don't know. It's really complicated for the industrial to make the decision. I know that some industrials are taking the decision. I'm not saying it's impossible. I think everything is possible, but with all the context, also international context, and sometimes some strategical choices between the different plans of a same group. Well, there are a sort of competition and internal competition inside the company. So I don't have a magic, a magic trick for solving this problem. But I think it's understanding the technology. What is the technology? What is the technology? Let's say, what are the good points, the bad points, etc. It's really important. And I see. When I had some exchange with industrials, and I agree with Stefan, sometimes you are talking with really experts in their domain in the industry, but they are not familiar with CCUS. And so it's really important with this actor that Stefan was mentioning, which would be the specialist for really explaining this, proposing the service, and helping to develop that. But it's not always easy to find this. And the last element, because I heard about that also in several conferences, it's also the risk sharing aspects. Because when you have different stakeholders, you have to share the risk of the entire value chain, and it's not always easy to define how the risk is shared between the different parties, because you need to provide the CO2 with a certain purity, etc. But if there is a leakage somewhere in it, it's the responsibility of the company which is managing the network or not. So it's always an aspect. So risk sharing aspects is also something that we need to take into account for all this problematic.
Absolutely great point there on the risk sharing aspects. And I think it's also kind of related to another question that came in just now from Mark, where he's asking about the different collaboration models. So on the one hand, stakeholders organized within one company, so vertically organized, or horizontally across many participants. Maybe Stephen, do you have an opinion on those two collaboration models that were brought up?
I mean, I think we should be open to mixtures of both, but I think it is inevitable that we will see collaboration across businesses and across, let's say, industry verticals. Cement producers produce cement, oil and gas companies bury the CO2 in the ocean, and somebody else manages the bit in the middle. Great, if you've got a diverse industrial company that can do 2 or 3 elements of that value chain, fantastic for you. But I think it is inevitable that we will need to be using, different companies, different entities with different specialisms.
Got it. Perfect. Oh, and I think, we are now at the 45 minutes mark almost. So I think it's a good time to go to the last question we have for today, which is a way to probably do a recap on all the things that have been discussed. And the question is quite broad, but it's around where to invest in CCUS today. Stephen, since you were talking about this last point, would you like to
think
start on this one?
This totally depends on what kind of investor you are. Because some investors, let's say early stage venture capital, they really like to look at startups with really exciting technology, but 2 years from now, the startup could just be completely disappeared. The risks are high, but if the startup goes well, valuation multiples go through the roof, and you've made a lot of money through the growth of the valuation of the entity. So, for, let's say, venture capital, growth capital, early stage investors, seed, Series A, Series B, look for some of the emerging technology providers, people working with MOFs, for example, or I've just seen someone put in the chat, super SSA, super swing absorbents or whatever. Great, go and find those companies, work out what they're doing, see which technology you like, and throw them a couple of million, right? But if you're an infrastructure fund investor, looking to put a lot of money on the table, but wanting to take as little risk as possible, or a very, very large bank with a similar kind of investment philosophy, not looking to put in equity, but looking to put in debt or bonds at very, very low risk, then there's no way that they're going to be going for an immature technology with a high risk of failure, even if the rewards are sensational. So they'll be looking for infrastructure investments. For example, they might be very, very happy to buy a fleet of 4 CO2 tanker ships where they can see there's an existing off-taker for their use for the next 20 years, right? Somebody needs a lot of capital to build these ships, but once they're built, there's a 99% probability that they will run and operate and generate cash for the next 20 years. A classical infrastructure investment, right? Pipeline's another very, very good example. If you build that CO2 pipeline, okay, it's an over-investment in the early days because it's not yet fully loaded, but you're assuming that more and more capacity will come on stream and more users will be using it, right? So when we say where to invest, what I'd really say is what's your, let's say, investment profile? What's your risk reward appetite? Think about some emerging technologies, think about some infrastructure, think also about some service providers, as we said before. If you like to invest in capital-light business models, let's say such as software or service provision, think about some of these systems integrators, these value chain integrators. They act more like consultants, not a lot of deployed capital, but a lot of, let's say, brain power and contracts and network. Maybe they've negotiated a lot of really fantastic contracts with other players. So when you say where to invest, what I'd really say is, what are you looking for? What kind of investment are you looking for? And then go and pick 1 or 2 players, 3 or 4 players within that kind of space, within that kind of profile, do due diligence on them, and then, get your money out.
Very true. Very true. Lionel, what's your take on where to invest CCUS today? And yeah, if you want to also include the answer for the supercapacitive swing absorption technology.
Yeah, well, I think Stefan was very complete on that topic. I would like to say that do not forget to continue to invest in the research. I'm not saying that just because I'm academic and I'm working in the research area, but we need to work on the world of today, prepare the world of tomorrow, and prepare the world also afterwards. So we need to invest concretely for establishing the CCUS value chain and having infrastructures, etc., finding the good actors for that. But we need also necessarily to continue to invest in the research, because it's through the research that we will find solutions and cheaper solutions for the world of tomorrow. So that will be my last word on that topic. So, but I suppose everybody will say that. Researcher will say invest in research, and other actors will say, okay, invest in my domain. But I think it's important to invest at the different level, and starting from research is absolutely mandatory on my point of view.
Perfect. Yep. No, that makes sense. And I think with that, we are ready to move into just a quick glance on our CCUS database. So, and I think it's fine if we eat on some of the time for the questions, because we've been trying to address all those questions throughout the discussion, which I think was very productive. There are still maybe 1 or 2 questions that have not been answered, so I promise I'll leave a couple minutes for those 2. And if anybody else wants to submit some, please go ahead and do so. Just wanted to quickly bring some of the insights we can typically get out of our what we call CCUS database. And so one of the things that we've been talking about have been around kind of where to invest in CCUS, or what are some of the leading sectors in here. So typically when we see, and you can see here on the right-hand side of the slide, the different industries that are looking at CCUS in terms of number of projects, it's quite clear that the power sector, energy sector, followed by chemicals, oil and gas, and direct air capture are sort of leading these space with respect to carbon capture. When we look at the different projects across the world, it's actually quite distributed as well. There might be some industry sort of differences between the different locations. And then when we also look at the types of technologies, as you can see here, the different colors represent the different types of technologies. In this case, we can see that's primarily the solvent-based systems, which are these violet type of bubbles here. But then there are some of the other technologies out there as well, such as like the sorbents, the membranes, and a couple of cryogenic as well, but still dominated by the solvent types. And when we take a quick look at what's being under construction or closer to commissioning, so again, the short-term future, we can see that there are a couple of changes here. Maybe the most interesting one is to see how direct air capture actually leads in terms of construction, in terms of number of projects here at these places, the power industry in this space. So definitely an area that's gaining some traction lately. Once again, if we look at the geographical distribution of those, we can see that it remains quite distributed, but we might see that there is some more concentration of projects, for example, in the US, across the Gulf Coast, Texas. In Europe, it's primarily around Western or Northern Europe, and then to a lesser extent in Asia Pacific and the Middle East as well. The trend with respect to the type of technologies, even the ones that are, once again, closer to commercialization, it's still the same around the solvent-based systems, which isn't surprising based on their maturity, but still there are a few players working on some other type of technologies. I think one of the other questions that we discussed today was around what's holding CCUS back. So what is it that's in the way for commercial or industrial deployment there? I think we talk about many things about the different business cases. We talk about the costs, the collaboration models. I think when we look at the issues reported in different projects, we can see different reasons, such as from performance or failing to capture the amount to be captured. Public perception, I think, was mentioned too, or political perception, as Lionel was saying, for example. Then market involves everything from off-taker agreements all the way to, for example, we look at some of the different projects, like Project Bison here in the US, that was one of the biggest direct air capture hubs to be built. The main problem was to secure sufficient carbon emission-free energy to operate that. So this goes back again to the infrastructure that is not just the pipelines or transportation and storage, but then it's also the integration with energy systems as well. Maybe the last thing I wanted to mention here, or almost last thing, is around the collaboration methods. I think the UK, with their hubs initiatives, has found quite a good way to deploy CCUS at scale. So, for instance, when we look at the East Coast cluster, we know it's actually combined of a couple of clusters or hubs by itself, such as Net Zero Teesside. That once again, it has multiple different projects inside Net Zero Teesside itself. This shows also that the collaboration can many times come throughout organization collaboration, but then also setting up some of the rules or fundings through public support. So we can see in this case the Net Zero plan here. It's under construction, where, for example, Shell with their cancel technology, but then there's multiple partners and participants that are part of these type of projects. Finally, when it comes to innovation, we see a lot of new technologies. Many of those have been mentioned here, and that they are at different levels of maturity, as you can see in these graphs, from TRL 9 all the way to TRL 3 or 2, where we have a lot, around like almost 100 technologies at TRL 4, which are very interesting ones, such as the ones that were mentioned before, in ionic liquid, for example, or demixing solvents, but then also very interesting electrolytic type of technologies, even away from direct from point source capture or even direct air capture. So we've been seeing some developments in the direct ocean capture type of technologies that have quite good potential based on the comparison of the energy consumption with direct air capture. more innovative things too, such as the CO2 batteries, and combining that with the overall system of the fuel cells and the infrastructure. So we believe that there's quite an innovation there, and could not agree more with Lionel mentioning how the investment in the research side would shape the world for the future in here. So we just wanted to share a couple of insights from our CCUS database. And since we are approaching the end of the hour, just wanted to make sure that we cover all of the questions that were submitted. I think there was one from Rafael that we didn't directly address, at least so far, which is around the monitoring, quite an important topic too, the monitoring of the stored CO2. The question is around the regulations, is whether this is solved or not at the moment in terms of the regulations, and what are some of the operational costs of monitoring that stored CO2 underground. Lionel, Stephen, any of you that would want to share some comments about this question?
You are muted, I think, Stefan.
Sorry, I'll learn one day. Thank you. I was going to say, I mean, in terms of plume monitoring, underground geological CO2 monitoring, whether it's under the water, under the oceans, where you can measure, pH levels in the water, or whether it's above ground, where you can look for background CO2 concentrations above local ambient atmospheric. The technologies to do it exist. The regulations to do it also exist. I mean, in the European Union, we've had CCS site monitoring regulations in place for years without ever knowing where or when to use them, right? Except for, in the Norwegian sector of the North Sea. So we've kind of been prepared for something that hasn't yet happened. In terms of costs, I mean, monitoring costs would perhaps be less than 1% of a CCS project typically. It's all going to go on the, as we said before, energy, the infrastructure, the transportation, the geological sequestration. Monitoring is an ongoing commitment, of course, but it's really, we've got the technologies in place. There's some good regulations in place in the European Union. They can be cut and pasted around to other parts of the world. And the costs are, let's say, minimal. The questions much more become, because monitoring is not just something you do to measure, it's something you do to measure and mitigate. So the problem then comes, right, so I've seen a CO2 level which gives me cause for concern. What next? Because you can't just go and get all of that CO2 back and go and put it in a bottle and put it somewhere else. No. So if you've got a leaky, sequestration site, you've really, let's say, got a problem. So I think the monitoring is really good, but the question then becomes, what if you find a leak? What can you actually do about it in reality? Is there something you can really do with regard to the geology and the subsurface geology at meaningful cost? So I think really it puts a lot of pressure on people really doing the geology right in the first instance, making sure that the sites are selected are not leaky, that if it's next oil and gas field, that the wells are properly capped. And I think the more that we can invest that time and energy upfront before we do the CO2 injection, and then of course we're going to monitor. But if you find a problem during monitoring, it's really difficult to know how to fix it. So invest the money, get it right up front.
Excellent. Thank you, Stephen, for that. Well, we are approaching the end of the hour here. So what I wanted to do is to kind of close the webinar now. First of all, thank you very much for our two experts, Lionel, Stephen. Amazing insights. Thanks for sharing those with us. And then also, I wanted to thank all the audience, all the attendees. Fantastic questions. Thanks for the interaction and for participating, and we hope to see you again in some of our next webinars. So thanks everybody for joining, and have a nice rest of the day.